Alright, let me read you the fancy directions, and then you probably did a bunch of it already. Describe the domain and range of each rational function. We learned that a rational function is essentially just division of polynomials of the form f of x equals a over x to the n. Note that a is a non-zero real number, so like 1, 6, -2. And n is an integer greater than or equal to 1, so x to the third, fifth, something power. And question number 3, I asked you guys to punch that into Desmos, but I'll be using my graphing calculator, so I'm going to press on the bottom left. I'm going to click on y equals whatever's in my calculator and press clear. I asked you guys to use parentheses, so parentheses 2, try that again, open parentheses 2, close parentheses, and then the fraction is a division sign, and I asked you guys to do division of x to the third. Now, x to the third is how many x's? 3 x's. And then I'm just going to press graph on mine. And this is what our graph looks like. Sketch that. Quadrant 1 and quadrant 3. Now, it is important, although it's not on your, I'm not sure on Desmos, but mine, it doesn't have arrows. So go ahead and make sure you have arrows on there. Alright, so that was one of the tasks I asked you guys to graph. Now, one thing I didn't ask you to do, but we should know how to do, is labeling the positive and negative infinities. Lome, let's label the positive and negative infinities. Remember, you're going up, positive. There you go. Hana, do you want to do a vertical or horizontal asymptote? Echo? What is 0? Okay, we have to write either x or y. Correct. Remember, just like the last problem, if you make a table of values and put order pairs that are on here, you'll recognize that all of your y values are 0. Courtney? Vertical asymptote? What is 0? The x value is 0. Same thing, if you make 3 order pairs, you'll recognize that the pattern is all your x values are 0. That's basically an equation for the vertical line, x equals 0. Okay? Alright, let's go ahead and do domain and range. Put your pencils down. The domain, we just learned, goes from left to right. And I'm going to write my domain down here. Just watch. It's more important that you're watching. I'm going to start my pencil or pen on the left side with a vertical line, just like this. And the question is the graph over here on the negative numbers? The answer is yes, because this arrow tells you the graph continues on forever over here on the negative numbers. So yes, there's a graph, so I'm going to write negative infinity. Now with infinity, you always have a parentheses. So we're basically saying there is a graph over here at negative infinity. Okay? Now as I move my graph towards the right, I have all the negative numbers, but then I'm stopping here on the x-axis at 0. It's saying, Friday's lesson was saying, well, this vertical asymptote, you can't touch this. What does that mean? We can't include 0. Now, this is new. Union. Class, what does the U mean? It's going to combine the left side of the graph with the right side of the graph. So as I go from the left side, this is negative infinity to 0. And on this side, as I go from left to right, I have the graph here at 0. and the graph keeps going to positive infinity. My domain is negative infinity to 0, union 0, infinity. Okay? This is basically a fancy way of saying don't include 0. This is interval notation, so hopefully you, I think we talked about that earlier this year. So again, the domain refers to the x values. Let's talk about the range. Before I move on to the range, I want to show you guys a hint. The hint is the vertical asymptote, the pink one, is actually right here. Let's do the range. The range, you will move in this direction, bottom to top. Put your pen at the bottom. Let's do it together. Class, what's the first thing I touch in red? It is an arrow. The arrow goes where? Forever. And where are these numbers coming from? Negative infinity. Let's write that. Range starts at negative infinity. Okay. Class, can the graph continue all the way to positive infinity? No. There's a stopping point. Where's the stopping point? At 0. So let's write 0. What do I write next? A union, because there's two parts of the graph. There's a start. We have to end it and start it again and end it. So now I'm above the green line. What should I write? 0. And these are all parentheses because it means don't include. Don't include. Because the graph will never touch the horizontal axis. And then I end where? Positive numbers, so that's positive infinity. Your range is negative infinity to 0, union 0 to positive infinity. And remember, your hint is the horizontal. Now I want to show you guys one other tip. It was helpful for me to see this. I'm actually going to turn my paper sideways. And I want to focus on the range, which is the y-axis. And why am I turning this sideways? I want you to see that it's like another number line. There's graphs from the negative numbers to here to about 0, and there's a graph in red from 0 to positive infinity, positive numbers. Now, it does not matter if the arrows are pointing up or down. It does not matter. The only question that really matters is there a graph? Yes, 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 yes. On the green line, no. Yes, 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 yes. Okay, so the only part of the graph we don't have is 0. And that's domain and range of the rational function.